Okay, so this is the course of analog communication. So what we'll do today, this is probably the first class, so we'll briefly discuss about what should be the outline of this particular course, what are the things that should be generally conveyed through this course, and what are the concepts that will be built up in this course. So that should be our first target. So initial 1 hour probably will be spending on that, and basically we'll try to capture what we mean by communication as such, and where it is required, what are the basic terminology that is being used in communication, why those things are required, and then we'll go into the depth of communication, and especially the analog communication. Okay, so whenever we talk about analog communication, before even talking about analog communication, let us try to see what we mean by communication. So communication generally means that we have some source of information. So if I just say some source of information, that might be generated from any kind of source, like it might be just voice, like now I am talking, so this can be a source of information because my voice actually contains some amount of information. It might be just a video you are watching, it contains information, it might be some pictures, it might be some text, whatever it is some source of information. It might be from any particular kind of source, but first we have to take the source of information. This source of information might have a originator, or it might be originated from some particular place. In communication, what we mean that somebody else, we need to transmit, or we need to actually transfer this information as fast as possible. So that's actually communication. So basically there should be a recipient, or I should call a receiver. It might be far away from the source itself, and source should be associated with a particular transmitter, which will take those information, convert it into a particular form of signal. We'll discuss about that later on, and then transmit it through a media which is very important in communication, which is called channel. And through the channel, at a distant place to the receiver, it will be transmitted. So basically if we just define, that's where the message signal comes into picture. So from the source of information we get the message signal. It might be we'll discuss about what kind of signals can be generated. We have just briefly told that it might be voice, it might be picture, it might be video, it might be just computer generated data, whatever it is. So that has to be first transmitted, and this is here, it is called transmitted signal. We'll see how the message signal and transmitted signal are different. There must be, this transmitter must do some processing on the signal to make this communication sustainable and make this communication successful, and then it will be launched into a channel. So channel is a very important part of communication. That's the thing which actually either physically or virtually connects the source to the destination, or transmitter to the receiver. So it might be a wireless channel where we just transmit it or radiate it in the wireless in forms of antenna or other means, and then it will be just propagated through electromagnetic wave through the channel, and it will be received at the desired location or receiver. So that's one form of channel. There might be channels which are not like this air, so it's like a wired channel, like our twisted pair earlier being used for telephony, or it might be coaxial cable that is being used for television transmission, or it might be recent advancement which is coming up, it's called fiber optic cable. So it might be any kind of channel that effectively transfer this transmitted signal through it. Okay, so that's the functionality of the channel, and once this is being transmitted, we should be able to get some received signal over here, so after the channel. Now you might be asking, should this transmitted signal and received signal be same? Effectively not. So channel does something to the transmitted signal. What are the things that channel does? That's also another very important part of communication. So we need to know exactly what channel can do to my signal, and we need to know how to really combat any kind of impairments it puts on the transmitted signal, because transmitted signal is my information, or it is carrying my information. So I need to exactly know how it is contaminating my transmitted signal, and then in the received signal, whatever we get after this contamination or distortion, we get it to the receiver, and then receiver does something to get back to my information. So it's that information. So we have to think about as much faithfully we can actually put from source to receiver, better the transmission quality, better the communication that we are looking for. So it's very important that whatever information we are transmitting, suppose we are sending an email, and that is faithfully transmitted over this entire chain, then only we'll say that that's a valid communication. Because if I write something and that writing is being distorted with some grammatical mistakes, spelling mistakes, some words missing, that will not be faithful representation of the input source information. So that's very important, that whatever we do in between in these three blocks of transmission, channel, of course we don't have any hand, we don't have anything in hand. So in the transmitter and receiver block, knowing what the channel is, so we need to very clearly know what kind of channel we have, or we need to use or choose channel, what kind of channel we should use for a particular transmission. So knowing all these things, how do we really do my transmission, and how do I do or employ something at the receiver side to get back my information faithfully. So this is what communication actually does. So if just we have to say some examples, there are plenty of examples, you know. Telephony is one of the probably oldest example of communication. So where whatever voice signal we generally generate, so what happens, there are a few steps whenever you do communication. So the steps are, first, step 1, generation of message signal. Okay, so that's probably the first step. Now that's like I have taken that example of voice communication, or you can talk about video communication. Okay, so or broadcasting video, so all those things. So whatever you do, first you generate the message signal. So like I'm communicating, I'm talking, so that is the message signal. It contains some amount of information inside it. So first generating that message signal. Then what we have to do is, second step, that we need to describe this message signal in terms of some set of symbols. Okay, so this set of symbols will be mostly electrical. So it might be like I'm creating, or I'm just delivering a speech. Now this speech signal, there will be a transducer most probably, which will actually convert it into a equivalent electrical signal. So that we can say that that is some symbol set. So it might be just voltage level of that electrical signal. So over time, whenever I am varying my speech or my pitch and all those things, all those quality of my speech, accordingly it will be translated to a equivalent electrical signal, which might in time. So if we plot that in time voltage, so it might look like something like this according to my variation. So this particular signal, so we can call that as set of symbols. So it might be just time varying voltage level or time varying current level, whichever way you want to represent it. So it should be that message signal through a help of transducer, whatever form that message signal input signal has, it must be converted. Mostly we are talking about electrical communication, so it must be converted to equivalent electrical signal. So that's the first stage. Okay, so or we should say second stage. The third stage of this communication is then we need to encode these symbols into a suitable form that can be transmitted over this media, whatever channel we have. Okay. So, what do we mean by suitable form? So, already we have got this electrical signal. Is that good enough for transmission? So, this is where transmitter, we have talked about those three stages. So, this is where after the transducer, when my equivalent signal, maybe voice or video, whatever it is, that is being converted to electrical signal. Now, it is my task to actually convert this into a suitable form. That will be another signal, of course, but that should be suitable form so that it helps in transmitting. Okay. So, this is for the transmission purpose, we need to convert it into a suitable form. So, there are multiple suitable form, we will discuss about them, but right now I am just giving one example. So, one suitable form is, first of all, we need to modulate this signal. Why modulation? That probably right now it will not be very clear, but we will come back to that, why that signal needs to be modulated. But right now we just take that it needs to be modulated. What do I mean by modulation? So, basically this signal has to be rided by a modulator. Okay. So, what is our modulator? So, modulator generally is a sinusoidal carrier. So, it is a high frequency sinusoidal carrier. Okay. So, we can call that as either sine some a sine omega c t of frequency omega c or 2 pi f c, or it can be even represented as a cos omega c t, any form of sinusoidal which has a frequency which is represented by omega c or equal to 2 pi f c. F c is the frequency of that sinusoidal. Okay. A is the amplitude of that sinusoidal. Now, what we need, what we mean by converting into a suitable form is this, that this particular sinusoidal we take that as carrier, like whenever we are sending a suppose letter. So, what we do? We put it in some envelope. It is almost means this carrier particularly is almost serving the purpose of an envelope. So, it carries the information and at the end it delivers that information, and after that it is not required. So, basically we put it inside the envelope, like we whenever we mail anything we put inside an envelope, then envelope is carried, and then after that the envelope will be opened up, the letter is delivered, then the envelope has no value. Okay. So, similar thing, this is a carrier, and on this carrier we try to put our information. So, suppose let us say our information is, let us take an example, that our information is something like this. This is one typical signal which is like our information. So, let us say it is a we all are familiar with binary or digital form of data. So, let us say it is 1 0 1 and this is actually time. So, this is the signal we want to transmit. So, what we do is eventually like this, we have the carrier, we have already seen that the amplitude of that carrier should now vary according to the amplitude of this particular message signal. Okay. So, this is our message signal converted to electrical, and now we have a carrier which is like this, a sinusoidal carrier, and the amplitude of this carrier, which is this part, must be varying over time, which almost mimics this message signal. So, how this will look like if I modulate it, it should be looking like this. So, basically the amplitude should be having this envelope, inside the carrier should reside. Something like this. So, what is happening, as now you can see the carrier almost remains the same, its frequency, its oscillation period and everything that remains same. what's only happening is the amplitude of the carrier is instantaneously varying as the signal, message signal is varying. So, it means that this particular carrier is carrying that message signal on top of it like an envelope, and it is being carried over the amplitude. Okay. So, there can be another way of doing it. Any sinusoidal is characterized by 2 or 3 things. Right now we will take 2 examples. One is its amplitude. So, whenever we write sinusoidal, it is A cos omega ct, right. So, the amplitude is one part of it which characterizes a sinusoidal, or it is a parameter of the sinusoidal. Another part is this frequency. So, now I have the option of varying any of them. Okay. So, either I can vary this amplitude, which I have done over here, or what I can do, I can keep the amplitude fixed and I can start varying this frequency. Okay. So, if I wish to vary the frequency, how it will look like? So, the same thing, if I modulate with this particular signal, it will look like this. So, suppose I have this particular portion 1, this particular portion 0, then 1, then 0 followed by. So, in 1 I will be giving a frequency which is higher. So, this will have higher frequency, and then while 0, this frequency will be slightly lower. Okay. That means the oscillation period will be, means the time period will be higher, and then again 1, so it will be high frequency and so on. So, what will be happening, if anybody sees this, it is actually there is a central carrier, and as we are transmitting different kind of symbol, let us say for this case 1 and 0, 2 voltage level actually. So, basically the carrier frequency is varying, it is becoming, suppose I have carrier frequency omega c, so it is becoming omega c plus some delta omega at this moment, and it is becoming omega c minus some delta omega at this moment. Okay. So, that is another way of varying things. So, basically what will happen, now you can see, if I transmit either this signal or that signal, at the receiver end I will be able to actually decode my symbol, because I know either if I know this is means modulated at the amplitude, then I know I have to just track the amplitude of the signal, how it varies with time. Forget about the carrier, this internal variation I can take out, I can just track the amplitude and I can roughly get the signal back, or otherwise I can just try to see what is the frequency and how it is varying. So, if I just track the frequency, I can immediately see this is the portion where high amplitude is being transmitted, because high frequency is being transmitted. This is the portion where low frequency is being transmitted. So, therefore, automatically the message symbol should be having low amplitude. So, basically either this or this will have the same representation at the receiver. Okay. So, this is where the third step, we were talking about this third step, encode this symbol suitable into a suitable form of signals which is good for transmission. So, this is what we are trying to do over here. Now, you might be asking why we are actually, we could have directly transmitted this signal, why we are doing these things. So, that is the first question probably will come to any communication engineer's mind, why we are doing these things. There are few reasons. Of course, the reason will not be directly clear right now, but probably little bit ahead in the course it will be much more clearer. But right now we can just say some reason. One of the reason is, see, look at the carrier, deliberately I have chosen very high frequency. The reason is, generally whenever you are transmitting, suppose you are transmitting through an antenna, okay, and you are receiving through an antenna, let us say it is wireless transmission. So, we are actually putting an antenna. Now, the antenna designing guideline is, if you have read already antenna designing guideline and a little bit of electromagnetics. So, you know that if whatever electromagnetic wave we are putting, so whatever that sinusoidal carrier will be putting, that will be converted to the equivalent electromagnetic wave of the same frequency. Now, whatever wavelength it has, the antenna dimension should be equivalent to that wavelength, or okay. So, now if I just transmit it at a very low frequency like this one, this might be having lower frequency, it's varying slowly, like the voice signal, it varies very slowly, it has the highest frequency component which is just 4 kilohertz. Okay, so whatever voice tonal quality we have, it has the highest frequency which is 4 kilohertz. Okay, so and many of them, many of the components, voice components, are even lower frequency, starting from 300 hertz to almost like it doesn't go up to 4, maybe 3.3 kilohertz or something like that. Okay, so if you take those frequency component, it's very low frequency. Correspondingly, the wavelength will be very high. And what will happen, the antenna size, because that has to be equivalent to the wavelength size, that will be very big. So to make a transmission, I have to build a huge antenna, very big antenna, maybe size of this building and all those things. So that's not really desirable, that I want to make a point-to-point communication between one person to another person. Suppose he is carrying a mobile phone through which he wish to communicate, and his antenna is very big. That's not feasible or practical. So that is why we need to, whenever we are transmitting things, the frequency component of that has to be really high, because we are radiating through antenna, and antenna size, if we wish to faithfully transmit and receive that signal, antenna size has to be comparable. Okay, so that's one thing which is required. So immediately it comes to our mind that maybe the frequency has to be translated, or the frequency has to be very high somehow. I have a voice which is having highest frequency component, probably 3.3 kilohertz. Can I take this to somewhere higher frequency? So one way of doing it, later on you will see mathematically, right now we are not saying, we are just stating that some way of doing it is this modulation, or putting it inside the carrier. It will actually take it, translate it into a very high frequency, and effectively what happens, your voice modulated with that carrier will have a very high frequency component, and correspondingly antenna size requirement will be very low. Very small size, tiny size antenna will suffice. So that's one very practical reason why we need to do modulation. The second reason is, which probably will not be very clear right now, but I am just telling it. See, on the air, if you wish to communicate, that's always true, that if I wish to communicate, what I need, this particular air media is a shared media. Okay, if I wish to communicate, so everybody else needs to communicate, and they want to communicate whenever they wish. If two of us are trying to, or multiple of us are trying to communicate simultaneously to multiple other fellows, and we are using the same media, what will happen? They will actually come into the same media and they will collide. Whatever information we have, they will get mixed, and then it will be very difficult at the receiver end to actually segregate them or separate them. Now what I am saying without any proof, later on we will prove that this modulation basically segregate these things beforehand. So whenever we are transmitting, what we do, I am just telling you the technique, later on we will prove that that technique helps. So we actually choose different carrier frequency. So for my transmission, suppose station 1 is trying to transmit to station 2, okay, wirelessly, and station 3 simultaneously wish to transmit to station 4 in the same media. Now what he can do, he can take a carrier frequency of f1 and he can take a carrier frequency of f2, where f1 is not equal to f2, to two different frequencies, and there are some criteria, what should be the separation between them and all those things we will prove later on. But right now what we are saying, that if they choose separate frequencies, then there is a possibility that both the signals can coexist in the same media, but they will not superimpose. Basically they will have different frequency location in the frequency domain, and you can later on, you are all probably aware of filtering at the frequency domain, so you can always put band pass filtering to choose your own carrier, and then you can demodulate it or you can get your signal back. So this is one way of multiplexing multiple simultaneous transmission into the same media without disturbing each other, okay, or without interfering each other. So that's another reason why we should actually put a signal into a carrier. Okay, so these things will be far more clearer when we define them more clearly and mathematically. Okay, so now going back to our steps. So, we have discussed about third step, right. So, what should be the fourth step? Fourth step is, so we have already encoded into a suitable form. So, whatever may be the requirement, we have now discussed about that, and we will be actually doing that at the transmitter side. So, this is being done at the transmitter. So, and this part is being done, this is the source where message is generated, this is where the transducer convert it into electrical signal, and then from that electrical signal we actually generate a suitable form which can be transmitted. So, that is the duty of the transmitter. And then after the transmitter we actually transmit it over the channel. Okay. So, that might be done by the help of media or any other form that is required to transmit. Okay. So, means this has to be by antenna probably I was talking about. So, you can put antenna, suppose it is wireless media, then put through antenna, convert it into electromagnetic wave and radiate it over the channel. Okay. So, this is the transmission part. After the transmission part, in the receiver side we need to have some more things. So, if I just go to the receiver part, there whatever encoding we have done, we have to, it is like that envelope, we are putting our letter inside the envelope. At the other side, if I wish to get the message, we have to open the envelope, we have to tear apart the envelope, get rid of that envelope and then read the letter, right, or get the message. So, we have to do the same thing, the reverse process. So, here we are putting inside envelope, that means we are modulating. So, at the other side we have to accordingly demodulate the signal. So, that is the fifth step. Fifth step is decoding or demodulating. So, we are just writing it decoding, you will see why that is written as decoding. There are multiple other steps also other than demodulation. Demodulation is one of the steps. So, decoding is the fifth step, and sixth step is from after decoding, it's again it goes to the transducer, because finally I want to hear it. So, it should be in my speaker. Okay. So, that it's reverse form of transducer or another transducer which convert the equivalent electrical signal into the voice signal if I or speech signal if we wish. So, recreating the original message signal. So, that is the 4 steps which are involved over here, and in this 4 step, as we have discussed, our focus will be the transmitter and the receiver, what transmitter does and what receiver does, and we have to also choose a media accordingly or the channel accordingly, and we need to be aware of what actually channel can do. So, we will next see what are the different characteristics of channels. Of course, we will not go into the details. Right now, we are just touching upon all the topics which needs to be really discussed to actually deal with a communication system. So, what we have so far understood that for a communication system, there must be a transmitter. Okay. Before that, there must be a source and the transducer, which are not part of the transmitter. It should be anyway there, because otherwise you cannot generate that signal. Once we get the signal, after that we need a transmitter which encode the signal. We have seen one form of encoding which is called modulation. We will see other form of encoding also later on, and then it goes into the channel. Then channel we have to choose accordingly, should we choose wireless channel or fiber optics or coaxial cable, some transmission line, twisted pair, whatever that media is, we have to choose, and we have to also know the characteristics of that channel. So, that is very important, that we need to exactly understand the characteristics, so that we know how the transmitted signal will be actually interpreted at the other end. So, received signal will not be equivalent to the transmitted signal. We will see that in the next particular section. We will be discussing about that, how channel actually degrade the performance and how the channel actually change the signal quality. And then from the received signal, we need to know how to again decode our signal to get the message back. Then again a set of transducer followed by means whoever is actually getting the information. So, it can be done. Okay, so this is the chain of communication. Now you might be asking what are different forms of communication that exist. We have already discussed about point to point communication, so which is like from one particular point to another particular point, or one particular person or one particular source to a particular destination. That's one form of communication we all are aware of, starting from telephony to computer communication and all those things. But there is also another form of communication which is called broadcasting. So like radio or television, where the source is unique and he transmits, that transmitted signal must go to multiple receivers simultaneously. So basically the information content remains the same. Whatever in broadcasting, suppose radio, whatever is being transmitted, it's not unique for a particular receiver, it is same for all the receiver, and it has to be simultaneously transmitted to all the receiver and decoded simultaneously by all the receivers. So that's one form of communication that we already are aware of, broadcasting. The other form is point to point, which is we call it unicasting, one particular point to another particular point. There is in between some other things which is called selective broadcasting, or which is also termed as multicasting. So there, if I have multiple receiver, not all of them I intend to transmit, I might choose some of them, but I'll still be transmitting same content to all of them simultaneously, okay, whomever I choose. So these are the different forms of communication that we are aware of. We have seen that there are examples of those communication. So what we'll do in the next section, we'll start talking about our channel. What do we mean by channel and how it actually affects our transmission, and why it's very important to know the channel very well before we actually devise a communication mechanism.